Hey, everybody. Welcome to another meeting of the Research Triangle PowerShell User Group. My name is Mike Kanakis, and tonight we're going to be talking about Azure Bicep. Tonight, our presenter is Jeremy Brown, one of the co-leads of our group. Hey, Jeremy, how's it going?
How's it going, Mike?
We have been talking about this a lot, Jeremy, and we went back and forth, and so we're just going to give a little level set for the people that are watching at home and for the people that are joining us in person. Tonight, we're going to be doing more of an intro to Bicep. Is that correct?
Yeah. Tonight
Yeah.
we'll start with kind of the primer. When we first started talking about this, we wanted it to be more of a real-world approach to Bicep, but I like the idea that we've gone with, which is breaking that apart. The second half of this is going to be more functional, um, real-world configs or declarations inside Bicep to build out actual services in Azure and glue them together. But before we get to the walk-run phase, we need to crawl. And so the part one side of this is going to be a primer on, what is Bicep and Bicep concepts, and just some simple deployments that are going to work through how you create a Bicep file in its most basic stance before we move to the more realistic, real-world kind of approach in part two.
All right. So the reason I brought that up is for the people that are watching at home. If you're watching this on YouTube, we recorded this in August. And so we usually get our videos up pretty quick, which means this video will probably be online by the end of August, early September at the latest. However, we don't have part two scheduled yet. That will be later in the year. We're still working on the schedule for that. So if you're interested in the part two, just keep an eye on our YouTube channel and we will get the meeting posted. And if you are watching this at home, we'd like to invite you to join us in person. You can visit us at rtpsug.com or on Meetup, and then you can join us and you can ask questions in the meeting. And so with that being said, we're going to get started here in just a minute. So Jeremy, maybe this was a super interesting thing to talk to you about when we were planning this. And so I don't have a ton of experience with building out infrastructure in Azure. I'm an identity guy. And so I'm familiar with the concepts, but I'm not familiar with the pitfalls and the roadblocks and what Bicep kind of works with. So maybe you could give us a little bit about what you're doing today, what your function is, and why Bicep is interesting to you.
Yeah, sure. So today I support a large manufacturing organization. Um, we're actually currently migrating our last physical data center into Azure right now. At that point, everything we have will be in Azure with the exception of the parts that are required to be on site in the manufacturing facilities. So my job, I'm responsible for the plumbing of Azure. So I deal solely inside the infrastructure of Azure. And then I have a second part of my job, like that's probably 80%, and then 20% is supporting um, the machine learning and data science side of the house with our grows and whatnot. So I spend most of my day now um, dealing with making sure Azure resources are where they're supposed to be and the way that they're configured the way that they're supposed to be.
All right. And so we were polling the audience before we started this recording, and most of the attendees that we have in with us this evening are new to Bicep or familiar with the concept, but have very little practical knowledge. And so I'm going to turn it over to you, Jeremy, with just the leading question is, um, what what problem does Bicep solve? And I'll leave that with Jeremy. I think he's got that coming up in the first one or two slides. But we're going to let you know what the benefit of Bicep is, and you'll see that apparent in just the first few minutes. So if you're unsure about what Bicep is or why you should be interested in it, just stick with this. It's going to come very apparent here very quickly. And so, Jeremy, I'll hand it over to you. Take it away.
All right, cool. So for everybody, my Twitter handle and GitHub are on the title slide. Everything that we look at today, to include the slideshow, is in my GitHub. So feel free to head over there. And then probably sometime tomorrow, I'll get this all uploaded into RTP SUG um, meeting repo as well. So this will exist in two places. Feel free to go forth and grab whatever you want from what you see tonight, if it will help you. So the first thing is a history lesson. What is ARM? So Microsoft has the what's called the ARM fabric, right, which is their backend for the way that they handle um, creating, managing, and deleting resources and all of that. And in fact, when you go and use, the web portal.azure.com and build something, it's just auto creating some JSON for you in the background already anyway. To the degree that when you go do that, you can actually go see that JSON that got created and save it and then use it to redeploy again later. So whenever you do that, what you're actually downloading is an ARM template. It's just an ARM template that doesn't support extensibility, we'll say, right? Um, and so ARM template stands for Azure Resource Manager Template. So, and it's a template that the Azure Resource Manager fabric is going to use to invoke work to meet that requirement. So one of the interesting things about an ARM template is, coming from PowerShell, we're used to, more functional programming, right? So we're going to write um, individual steps, or we're going to create functions, which are blocks of steps. And then we're going to glue all of these steps and functions, which are blocks of steps, together inside a single PS1 script. And the script's going to go through and just start at the top and work its way down through all of those steps that need to happen, right? And as it works through them, it's gonna, we'll have conditions and we'll have cases and things like this. And in our code, we'll have the logic that the PowerShell interpreter needs to be able to make those decisions on whether or not work needs to be done, and then what needs to happen if work needs to be done. So an ARM template, we don't concern ourselves with all of that functional programming part, right? So an ARM template is a declaration, and what we're declaring is the end result. I don't care what it takes to get there. This is what I want. And so we're going to codify the output. I expect a storage account configured this way, all of these different settings. Now, what it takes to make a storage account exist in Azure, that's on the ARM fabric to handle. And that's one of the benefits of using something like this. Today, you may have already run into an issue where when you're going through the portal, it's like, oh, I can't do something. And then there's a drop down and you have to select create new, and then it takes you to a whole different window. You got to build something else first before you can get back to the window that you were working in order to be able to keep moving forward. Anytime that anybody's made a virtual machine from nothing, you've experienced this a bunch of times, because when going through the virtual machine, you need to choose whether or not you're going to use a managed disk or not. And if you're not, then you need a storage account. If you're using boot diagnostics, you need a different storage account. Your machine's going to have to be on the network because it's in Azure, so you need to have a NIC. And if you're having a NIC, you got to put it on a network. So you need a virtual network. And the virtual network's no good without a subnet, so you need to build a subnet. So the very first virtual machine you ever make, you're going to be you're going to be prompted with a bunch of drop downs that have nothing in them. You're going to be having to choose whether or not to make something new or use something existing. And since it's the first, you're just going to make a lot of new things. And doing it that way, you're going to lose out on a bunch of options that would otherwise be available to you in the creation of that virtual machine, because you're only going to get the bare minimums you need in order for the virtual machine to get made. When I build an ARM template, because I'm specifying the output, that I have a VM that I expect to be on a network, that I expect to have an IP address, that I expect to use a boot diagnostics, and the ARM template's going to it's going to consist of all of those pieces in one template. And then the fabric is going to say, oh, well, the output is all of these things. Well, I can't make the VM before I have the storage account, and I can't make the NIC before I have a network, and I can't make the subnet before I have a network. And it's going to figure all these orders out for you and then just go make it with no problems, and then return back to you the information that you requested, and you'll have your resource built. So another really big benefit that I like in using an ARM template actually comes the other direction. We'll talk about it later, but there's two modes for deployment. And so I always keep an empty ARM template, an ARM template that defines nothing at all. And then if you deploy that, anybody that's played in Azure, I'm sure has run into the point where they go to try to delete something and then they get an error because they can't delete what they're wanting to delete until they first go delete something different. They have to go delete that explicitly before they can come back to the thing they want to delete and finish deleting. Well, if you make an empty ARM template, then Azure, the ARM fabric, handles all of that. It's going to figure out what it needs to do for that to work. So if I deploy an empty ARM template, I'm saying I want this place to have nothing at all inside of it. And the ARM fabric will figure that out for me and then just go forth and do the good work. And what I'm left with is an empty resource group. And it's fantastic. So in a way of playing, it gets really easy to remove everything, not have to pay for it when you're done playing, without having to continually go through and rerun get my AZ resource and then remove my AZ resource, find some errors and then run it again and delete some other stuff and get some errors and run it 4 or 5 times before you delete everything. So the old way is the ARM template, right? And it's I shouldn't say it's the old way. What previously existed was only an ARM template. So and you can do everything you want in the portal and then some with an ARM template. What comes next is Bicep. So Bicep is a domain specific language that allows us to create that ARM template. So an ARM template, we'll take a look in a little bit, is just raw JSON. There's nothing more to it. And so we lose a bunch of functionality that we would otherwise get inside having um, a higher level programming language. A big one would be comments. In JSON, there's no way to make a comment. So when you have a really funky line inside your raw JSON file that's going out and doing something important, and you want to let people know why it's like that, or don't ever change this line, or something along those lines, you really can't. But inside Bicep, we have an opportunity to be able to leave that historical knowledge with the code uh, to exist forever, and the code that bicep file will still build an appropriate JSON file to be used by the ARM fabric. And so bicep isn't something that's replacing ARM, it's something that's added to ARM to make it easier for us to create that JSON file.
And so let me jump in there for a second, if you don't mind.
Sure.
And so to back you up, you could stay with the bicep, but to back you up to from the beginning. So some people may be wondering this ARM template stuff that you're talking about. There's probably a lot of guys that do infrastructure as code and are very familiar with ARM templates because they use it all the time. But there's probably a bunch of people that build VMs or networks or whatever, one object at a time, one off just when they need them. And so you're saying you possibly could never interact with ARM templates because the GUI gives you the ability to build objects. And when there's prompts, you're going to get prompted to build the things that don't exist to have to come along with a VM, like a network and stuff like that. And so an ARM template is just a way to build out a file to specify all the things that you want to repeat this process over and over again and build the network and all the related pieces exactly the way you want. That's the function of an ARM template, right?
Yep. Yep.
Okay.
It is just me codifying the output.
Yeah.
All I'm doing is codifying what I expect the end result to be.
Yeah. So to bring that around, if you're wondering why you've never used ARM templates, maybe you're in a situation where you don't build enough resources where you've needed ARM templates to date, right? You don't mind doing them as a one-off thing. And so that's maybe why you haven't come to the ARM template thing yet. And so Bicep, I'm foreshadowing here a little bit, Jeremy's going to get into this, is going to basically show you it's much easier to use Bicep to build your ARM templates because ARM templates can be tricky. And so is that a fair statement?
Yeah, absolutely.
Okay. So just so we paint the picture, if you're not used to ARM templates, it's a way to build infrastructure as code so you can build objects, resources in the cloud. If you've been doing that one off by up to this point, You've been using ARM templates, you just don't realize that the GUI is plugging in the options in the ARM template for you, and it's using it behind the scenes. This is a chance for you to build your own ARM template and specify all the things that you need in your build exactly. And then Bicep is a way to make that easier, which is going to talk about now.
Yeah. And I will say, if you're building it in the portal, it's the learning curve is not that steep for simple resources. And for me, I invested time into and learning ARM templates before I was ever dealing with Azure server infrastructure, purely to learn Azure because I'm cheap, and a lot of times I would rebuild the same stuff over and over and over again, while in order for me to go and learn some other new thing in Azure, because I still needed to have users to sync into an Azure Active Directory or something like that, right? Um, or if I'm wanting to mess around with scale sets and things like that, I still need to have VMs in order to play with and use those in my scale sets and whatnot. And so a lot of times you would remake the same resources as you're learning something, because I can't learn scale sets in one evening after work. But I also don't want to pay for a bunch of VMs for the 2 or 3 weeks that I'm going to spend investing my time into scale sets. And so what I did is I learned ARM templates first, and enough of a way to be able to recreate that VM. And then every night when I'm done learning, I throw it away. The next morning or evening when I come in to learn, I can just redeploy my ARM template and I'm back to the same environment that I was learning with when I started. And again, at the end, I can throw it away. So I'm only paying for those hours of learning time instead of weeks of all that time where I'm not learning, just to keep learning inside Azure. That was how I started with ARM templates. And then once Bicep came around, I quickly jumped at using them because ARM templates I thought were quite painful to build. And Bicep is a breath of fresh air when compared to the two of them. All right, so how do we get started with them? So here's some links. This will tell you how to go through and do the good work and getting it installed. And I went ahead and make big in this. Come on, there you go. So this is the top link that's on that slide, and this will get you to how to install Bicep. Bicep comes in two places. So it comes inside the AZ CLI. And so if you have the AZ CLI, then you just tell it you want to install Bicep. And then from there on, it will exist as something inside AZ. So AZ space Bicep, and then whatever you want to do, and it works. But since we're the PowerShell, we don't need all of this extra AZ stuff. And what we're going to do is we're going to just install Bicep manually. So there's a link here that will take you to the MSI, and you can just install Bicep as its own standalone component. And then when we're using Bicep, we'll just call Bicep directly inside our command prompt in order to either compile or decompile our JSON files. And then once you have those made, we can use PowerShell to do the rest of the work that we care about doing. So for
Let's
us,
give a
all
little
we need to do is grab that.
and let's give a little plug out here. I think I saw in the documentation when you were showing me yesterday that there's a chocolatey package for Bicep as well.
Yes, I believe there is.
Yeah,
I'm sure Stevie's already posted it in chat.
he has.
Yeah. So along with Bicep, I, I don't think it's possible to do this without also installing the Bicep extension inside Visual Studio Code. Uh, that is, I mean, just chef's kiss, right? So there's an ARM extension as well that I also install. I find it to be easier to read um, the raw JSON after I make a Bicep file if I ever want to go in and look at that. Um, and then when dealing with the parameter files, which we'll talk about later, you still do all of that as just a raw JSON file. And so the ARM template allows us to quickly make and lint those parameter files. So along with this Bicep extension, there's an ARM extension that I would really strongly encourage you to install. And we'll take a look at both of those here in a minute once we flip over to Visual Studio Code. And then the final slide that I have here is just a link of some of the basic fundamentals that I think would be useful for somebody to read when starting. These are each of the different core components of a bicep file. You'll have parameters, variables, resources, and outputs. And these are the documents that discuss how all of those work. So, and they exist right here as a parameter file, gives us structure, gives us some um, information about or examples on how to use them, and then the decorators that we can use and how each of those work across um, a parameter. And then here's the one for variables. Again, the structure or the syntax inside Bicep. Some examples on how you would use a variable. And then the basics on creating a resource and the structure and syntax of how we make one of those. And then finally, how do outputs work? So again, the syntax, some examples for outputs. Um, so these are the I would say the core reading. Won't take very long to read through this, and then over the first couple bicep files that you make, you'll probably be referencing this, and then after you make a few of them, you're off to the races and everything's going to be good to go. All right, so let's go and actually look at deploying some resources. Is my Visual Studio Code big enough, or do I need to make that larger?
I think you could bump that up 2 times.
2 times.
That's
Bigger than that?
passable. That's passable. It's good enough.
All right, there.
Yeah.
Got to take care of them old eyes, huh? All right, so I wanted to start this by taking a look at um, the structure of an empty JSON file for an ARM template, and that's what this is right here. So when you go to build an ARM template, well, actually, let's stop. Let's go over to here first. So like I was saying, you want to have, I'm just going to search for ARM. You want this Azure Resource Manager, the ARM tools installed, and then we can search for Bicep. You'll want this Bicep extension installed. So the benefits that you get from these are, like I said, it's going to give you some linting across whether or not your code looks right or not. And it's going to have a lot of the built-in resources and object types and things like that built into it. So as you go to create your Bicep files, it'll start giving you the IntelliSense to work through making it, which I find to be a lot faster than continually referencing the Microsoft Docs in order to find the object type that I'm trying to build in order to make it. So I don't, like I said, I don't think you can make these really, like these are required extensions in my opinion. All right, so back to this then. So right here, so we're looking at an empty JSON file, and with those extensions installed, so with those extensions installed, it's as easy as typing the word ARM. Well, it would be that if this was loading. Come on, we'll come back to that. But it would be as easy once this is done loading as typing the word ARM, and then it would build this out for me. This will give me a drop down, and this is exactly what it's going to give me. It's just this right here. And you'll notice there's parameters, functions, variables, resources, and outputs. So that should look very similar to what we just talked about with Bicep. The only difference is this functions exists here that doesn't exist in Bicep. We could still do functions in Bicep, but they're handled a different way. So, and a actual JSON file or that an actual template would look something like what you see here. Let's make that go down. So here's what an actual, we can see the parameters have been defined. There's a storage account type, there's a location, a storage account name, and then here we're defining a resource. That resource is a storage account, and it's got some properties on it. and then we're going to write out the name of the storage account and the ID of the storage account. So using um, ARM. And so this would have been the old way to do it. And like I said, this is anybody that's written JSON knows this isn't fun, right? So there's a lot here that you have to get right, and it's just not easily readable. It's not something that's very um, what's the word I'm looking for? It's not something that's very like accessible, right? People wouldn't look at this and think, "Oh, I feel safe making changes in here." And so what we get instead is we'll get Bicep, and so Bicep looks like this. So this is something far easier to read and gives us a lot of functionality that we wouldn't have otherwise gotten inside of JSON. So some examples down here at the bottom. So we get single line comments by using 2 forward slashes. We get multi-line comments by using /* and then */ at the other end. So that alone is a big win from JSON. Beyond that, reading through the parameters up here is pretty verbose, right? Like we come through here and we're looking at the parameter for storage account type, and then we have to define what it is and what its default value is, what's allowed in it, all these different pieces. Um, that's a lot to read and follow inside a JSON file, where if we take a look at something inside Bicep, it's all built right here. There might be a couple extra rows on top of it. We'll talk about those in a minute. So something super simple to deal with. Let's take a look at the one we've got. So the one we've got our parameter, which looks just like what we would have seen inside the JSON. And I'm defining the location to be East US 2. We've got a variable called resource group name that I'm defining to be RTP Sug Demos. And then I'm defining a resource, and we can see that that is a Microsoft.resources type. And the object that I'm building is a Microsoft resource group. And then the um, like API version, the endpoint that I'm using is this one. So April 1st, 2021. And I'm passing in the bare minimums for making a resource group, which is it needs a location and it needs a name for the resource group. And then once the resource group is built, I'm going to output some data, and that's what we see down here. So everything inside a Bicep file works by defining, what you're doing, whether it's a parameter, a variable, a resource, or an output, and then following the structure appropriately. So parameters and outputs will always be the name of the parameter or the output, and then what you're storing in that location. So we're storing a string here, so I'm defining that location is going to hold a string. Sometimes you might store something, especially when we're dealing with outputs, we might store something or output something that's got nested data off of it. So we might not be dealing with a string. We'll deal with an object in this place. Another one might be int. So if we come in and just do param foo, so these we can see here all of the different object types that we can store. So define as an array, a boolean, an integer, an object, string, secure object, and secure string. So just whichever one you want is what you would specify, and then you would pass in the data from that point, right? So we're not going to deal with that on this one though. We're going to leave it as it is. So yeah, so that's that side, and then down here, same thing. So I'm defining on the output what the key is going to be called. I'm telling it what the value, what the type is for the value, and then I'm defining the value on this side. So when we get through our output, I'll see something that says my var output, and it's going to give me the name that I passed in for the resource group. And then here we'll see my param output, and it's going to give me the value that I passed in on the parameter. And then here we're going to see the resource group location. And again, I'm going to output a string. And this time I'm going to grab the location as it exists from the resource that was deployed. So when we make a resource, the resource is built by giving it a value that you're going to use inside your code. And that's what this is. And then this is what's actually getting created. Everything on the inside is the properties required of that. And that's cool because once I build this, I can then reference this later in my code. So for the example, if I'm making a network card and it's going to have an IP address and I want that network card to be attached to a VM, then when it comes down to my VM to identify which NIC I'm using, I'll address it by however I've identified it up top in the resource group for the network card. And we'll see how that looks much later on in the talk. So for now,
Jeremy,
let's go.
we got
Yeah,
we got a question.
sure.
And so some of the guys are understanding what you're doing and they can follow along. But when you get to things like resource, my res group, and you picked a specific value there, they're not really understanding how you came up with the value. Like, where did you find that information from for the at
For the
21441?
this part
Yeah,
here.
API version.
yeah.
So for me, I default to the new version until it doesn't do what I want it to. It's just like think of the date as like an API endpoint, right? So I might have multiple endpoints, and where one method exists in the version 1 endpoint, it doesn't exist in the version 2 endpoint. My bicep files are the same way. The cloud moves so quick that I may have been able to use a property set in an older version of that object type than I can in today's version. And so Microsoft doesn't want to break um, everybody's deployment files as quickly as the cloud is moving. And so when you go to make something, and we can just do it real quick, resource, and then let's do Microsoft. What do you want to pick? Let's pick, uh, let's just keep typing. That's too much stuff. Dot storage. Yeah, so we'll just do a storage account. And this is something that annoys me. Always does that. So here I'm in the Microsoft.storage namespace. I'm going to build a storage account. And then when I come over to here and I hit that @ sign, we can see that there's a couple preview endpoints available. And then there's a bunch of production ones available that are all built off of different dates. So if we went and looked at the documentation, you would find changes between these different endpoints somewhere along the way. Sometimes they're breaking changes and sometimes they're very small things, like they've changed the allowed types to be passed in on a property. Used to, I could do free, basic, and standard. Now I only get basic and standard, right? And so if I want that free one, I'll have to backdate in order to take it to a point where the free is still an allowed value, something like that. Um, and so
So
for me,
it sounds
when
to
I'm
me
building
like,
something, go
go
ahead.
ahead. I was going to
I'll
say,
say
so it
so.
sounds to me like you're going to find an API that works for what you want to do and use that until it's, like you said, no longer no longer valid. So you stick with something that works. And then when you need to course correct, you reference the documentation and find APIs that are appropriate for what you're trying to do.
Correct. Yeah. So for me, I always pick the newest unless the newest doesn't work, because then I know that that code's going to last the longest amount of time before I experience a breaking change. But sometimes I'm wanting to deploy something in a way that this current value doesn't support what I'm wanting to deploy. So then you get to go play archaeologist and find the one that does support the way you want to deploy it, and you deploy it that way. I feel good.
Yeah. And so we had another question that's really not sort of appropriate at this point, and maybe we can table it and maybe it comes up at a certain point. But someone was curious about what's the difference between Bicep and Terraform, and why would you use one or the other? And I don't know that we're ready to talk about that, but maybe later on, if that comes up, we can talk about that
I
a little
mean,
bit more.
we might forget it later on. We can handle it now. The difference is the way you build it, and what it supports. So the benefit that you get from Bicep is a Microsoft tool set built in Azure for Azure that just works. Quote, I'm going to put that in air quotes, right? Because everything's got its quirks. Terraform is we'll call it cloud agnostic um, deployment model, right? Because I can put Terraform in GCP, AWS, Azure, DigitalOcean, right? Lots of places to define the infrastructure that I want to build. So the upside is it's cloud agnostic. The downside is it doesn't just work in anything. Anywhere you want to deploy Terraform, you first have to build those services into that cloud service provider for your code to then run against to provide that activity. And it comes with its own set of quirks. So in the end, they both create the same resources in Azure, uh, but the way you get to it is a little different. If I was in a job where I worked in multiple cloud providers, Terraform would be something I would look at. But for me, I don't do anything um, anywhere other than Azure. Azure's, I've hung my hat on that hat ring, and that's what I'm an Azure person. And so I do Bicep because it just works. I have less errors and I have less quirkiness using a Microsoft product to deploy Microsoft resources in Microsoft's cloud than I did whenever I played with Terraform. Now, granted, I am not a Terraform genius. I've made a handful of things using Terraform. Um, but that's why I look to Bicep and ARM over Terraform is I do just Azure. And if you learn any of them, moving to another one, just like any other programming language, isn't the hardest thing to do. It's getting through the first one of understanding how to make a declaration file that's going to do what I want it to do. This is closer to thinking like writing like Chef or DSC or Puppet. You know, think more like that and less like I'm writing functional code like PowerShell, Python, C Sharp, something like that.
So,
But
so Bicep is Azure specific, but probably a quicker start time, easier to get started with. Terraform supports more, but you need to do more work to get it to work.
yeah, without a doubt,
Yeah.
that's what I would say. Yeah,
Well, supports more clouds, but may not support more features. Because I
true.
think someone mentioned in here, Terraform does lag behind Bicep on the Azure cloud platform, just like it lags slightly behind CloudFormation templates for AWS,
Yep,
which is
that's very true.
AWS native sort of declarative language. But Terraform allows you to kind of bridge the gap between the two of them.
Yep, that's a good point. I didn't think about that one, but that's true. Yep, but again, you're looking at that cloud's declaration versus cloud agnostic. So that's your trade-off. All right, cool. So any other questions?
No, I think we're good.
All right. So let's take what we've got here and run a deployment. And I've added this into here so I don't screw it up. And oh, haha, I did screw it up. Let's talk about what Bicep does first. Uh, so there's two ways to deal with Bicep, right? So we can take a look here. Bicep is currently installed on my laptop right here. And if we do a quick dash dash help, you can see that Bicep it can do quite a few things to it, right? There's a lot inside this help file. The things that we care about today are the build operation and the decompile operation. There's not a lot, but there are a few other things that the Bicep exe can do for us, but those we'll look at some other time. Today, these are the ones that I care about. The Bicep decompile will turn a JSON file into a Bicep file. So was it Ed, I think, was saying you already have a lot of ARM templates in your organization, um, and you haven't yet moved to Bicep, or was it Stephen who said that earlier?
That was me. This is Ed.
Yeah, yeah,
Yeah, we have a lot of
yeah.
ARM templates, and we're just starting to look at will Bicep help us? But we
So
also use a lot of details. So I'm like, this may be too abstract.
so you can take your current ARM templates and pass them in through this decompile, and it'll build the Bicep file for you. Uh, I I don't want to give you a number because I don't know how you're using your ARM templates, but in my experience, Bicep is pretty good at building the ARM template for you. It might miss a piece here or there, but they're usually pretty small things that are easy to identify and fix. It doesn't generate like just a large file of trash that's not useful to you. Most of the time, it just works, and it'll build the JSON correct or the bicep file correctly from the JSON. There are a handful of times where you're doing some like weird conditional stuff that, or you're using an extension that exists in the ARM template that doesn't exist in Bicep. If you're using like an older extension, and that's where you'll run into some issues. But you already know what your ARM template looks like, so when you go look at the Bicep file, it's pretty easy to identify where that failure is. So for the most part, this is pretty good, right? And you can use this to go turn your ARM into Bicep very quickly, and then it's just auditing what it made in order to make sure it keeps working. And then the other option is the build option, which is how we're going to take a Bicep file and turn it into an ARM template with actual .json. So
Let
let's
me
look
let me
through.
let me ask you a question there for a second, because I'm
Sure,
a little confused on that. So I understand you're doing build now, but if we go back to the decompile, so if I have a bunch of ARM templates and I want to turn them into Bicep, my reasoning for do that would be because going forward, I want to then work in Bicep rather than ARM templates
correct.
directly. Okay,
Yeah,
so I can convert them into the file, and then it's easier to go forward, hopefully, with Bicep rather than having to maintain the ARM templates themselves. Okay.
yeah. If I'm moving to the Bicep way, so and this is kind of looking into some more of the stuff that we'll look at when we get into more of the advanced talk. But an ARM template, typically it does not, just like when we write a script, right? So we'll start writing a script and the script's good. And then as we iterate on it, eventually that script turns into a module. And then we start writing other scripts and we start importing the module of all the other scripts that we had been writing to keep using in the new script. You know what I mean? Like it just keeps growing, right? As you iterate. This is going to be the same way. So I might define the way my storage accounts look for everything inside Azure in its own file. And then when I go to make something and I need a storage account, I'll pull in the other file that has my create storage account in it to the file I'm making, and then use that storage account with whatever I'm doing moving forward. Kind of like I import a module in PowerShell to keep using it. I hope that makes sense. And so when you start getting, scaling this out to a higher level of extensibility, um, if I have a whole lot of ARM templates already built, I don't want to recreate all of those wheels by hand in Bicep moving forward. And so we can take all of that JSON from our existing ARM templates and convert them into Bicep files so that now that we're writing Bicep, we can keep using what we've already made. And so to an example to show that, right? So let's use this storage account right here. This is just a default ARM template um, that, it's just the raw JSON, right? And then if I come over here and I type in bicep decompile and then give it the JSON that I'm interested in decompiling. And if I added a second one, I could actually come through and change the file name if I wanted to. If I don't pass in that last parameter, then it'll just make a bicep file of the name of the JSON file. And here we can see what was a JSON file is now a bicep file. And so it works by both ways. We can take JSON ARM templates, turn them into bicep, and if we come back down here and we look at what we've got here, we can take our bicep specify build, example one, run that, and then this will come through and build an example one.json for me. That is the JSON file or the ARM template from the bicep we just declared. So that's how this works. Curious to know why that thinks that this is a failure. Let's find out if it really is. Okay, so, and then now that we have the, now that we have the bicep turned back into an ARM template, we should be able to take this right here. I don't know why you keep losing that. And then run the deployment, and then this will deploy what we've declared. So in this instance, my Azure subscription now has a resource group called RTP-sug-demos inside of it. And we can validate that. Let's just come over here, take a look under resource groups. And there's my RTP-sug-demos. And there won't be anything in it yet because we just built it, right? So that's kind of the flow that we'll use for turning Bicep into JSON and then deploying it. So let's take a look at another example. So here is a larger example of a Bicep file, and we'll start talking about a few other things. So coming from the first one, which is very basic, right? We just made the resource group. We had a single parameter, a single variable, and some outputs. Oh, I did want to talk about those outputs. So before we move forward, take a look down here. So we can see each of those key for the key value pairs on my outputs. So what I use over here on the left is what outputs over here for each of those things. And then the values on the right on the key value pair, and we can see that. And then what I want to point out is here, these two are less interesting to me, right? My output for the variable and the parameter, because those are the things that I brought in and put in myself. So we already know what those are. But what is interesting to me is here where I defined the resource group. Down here, I was able to take that and then identify the location property off of that and then get that out as well. So I asked it to be made in East US2, and then this one, I can validate that it really truly was made in East US2, because this one's coming from the resource that got created in Azure. That's the location that it exists, not the location I asked. And so here we can just see how that works. So I found that to be quite interesting. Okay, so now let's look at the next Bicep file. So we're going to step up just a little bit on this Bicep file. Everything's still the same structure as what we saw before. We've got parameters, variables, resource, and output. But we've got a few more options going on this time. So in my parameter, I'm passing in the string. And then you'll notice up top what's above it, these are referred to as decorators. There's a list of decorators that you can use in your parameters, and they're in that link I gave you for the parameters, and this is what they are right here. So we can define an array of the values that are allowed to be passed into that parameter. We can define a description, the max length, the max value, the metadata to include like descriptions, things like that, minimum length value, and then if it's like a password or something that we want to not pass in clear text, then we can add the secure decorator to it, and it will basically treat it like a PS credential, right? Like it would be a secure string instead of a clear text string. And so here we're taking advantage of some of that. So I've defined a minimum length and a maximum length of 3 and 11. So I can ensure that this value is never going to be bigger or that nobody could pass in a value smaller than 3 characters and larger than 11 characters. And then I've used the allowed decorator on the SKU to limit which values I'm going to allow to be made. In this instance, maybe I don't want expensive stuff to be used. So we'll get rid of the premium stuff. And I'll get rid of all this zone redundant stuff, right? So now I've reduced what's allowed to be a very small subset of all of the ways that you could build a storage account to make sure that nobody ever makes something too expensive. And in a storage account, that's not a big deal. But when you get into making VMs, for instance, and for where I work, we've defined a set of VM SKUs that exist for small medium, and large VMs. No VM should ever be made that's outside of those listed VMs for each of those types. And so I have defined those types of VMs here. And if somebody ever tried to go in and deploy a resource that isn't in a quote unquote approved VM SKU, it would fail in building the bicep file or deploying the JSON file. Rather, not building the bicep file, but it would fail in deploying the ARM template or the JSON when somebody passed in the wrong parameter, essentially. And we do that because we do a lot of VM reservations. And so I don't want somebody penny watching the Azure pricing sheet and trying to make a VM that looks cheaper to them without realizing that we're taking advantage of 1 and 3 year reservations in blocks of VM SKUs. And so we force them into making it on those VM SKUs. So underneath this parameter, we can see that we've defined another parameter down here, location, except this time, instead of passing in the location as a string, we're using a function for that. So their Bicep has a bunch of built-in functions that we can pass or use to dynamically build the values that we're looking for. So the resource group function is one of those. When we go to deploy this, we're going to define the resource group we want it deployed into. So when you call the resource group with no parameter inside of it, then you're always using that to identify what you used for your deployment value in PowerShell. And that'll make better sense once we see this in action. So, and then I'm just calling the location of that resource group that I've asked it to be deployed into, and then using that location to make the resource. So that ensures that I'm always creating my resource that's inside the resource group that I've asked it to be created into. Down here, we can see another one that's unique string. In this instance, we're going to create a unique string on top of the storage prefix in order to make sure that I don't ever have two things with the same value get created. And then in order to create a unique string, I have to seed it with something. And so we're seeding it with the ID of the resource group. So I'm going to use the ID of the resource group to generate some unique string. That unique string is going to get added to the storage prefix that we populated up top. And that'll be the entire name of my storage account. So we'll expect to see this to look like RTP sug, CT74X, whatever, right? Just a bunch of gibberish after it. So
Got a question.
sure.
Diego was asking about what you were just talking about prior. Can you reuse the decorator, or for each item you want to use, you have to write them again?
So the decorators are always defined above the value that they are decorating. So yeah, I don't know that, like, outside of like these decorators, you might want to reuse them. But so if I wanted my location to be no more than 15 characters, then I would add that max length decorator here as well. And now this max length goes to this parameter, this max length goes to this parameter. So you would always identify each of the decorators above the parameter that they apply to. Good?
Yes.
All right. All right, so yeah, so here we've come through, we've defined the parameters that are things that should be inputted at deploy time. We have a variable that we're using to construct the unique name from parameters plus some other stuff. And then we're going to take all of that to build a storage account. And we can see, I'm using the storage account or the storage namespace to build a storage account. And then I'm defining the properties that I want set on that storage account. I need a name, I need a location, and then I have to define what kind of SKU I want for that storage account. And then whether it's a version 1 or version 2 storage account, and whether or not it's going to accept HTTP traffic or not, is what I've chosen. There's a lot more that we could choose to deploy and set on our storage account, but this is good enough. And afterwards, at the very end, on my output, you can see I've identified this resource by STG, and then I'm going to output the name that the storage account made or got created, and then the primary endpoint of that storage account under each of these keys here, which is good, right? Because when I make this, I'm making RTP sug plus a bunch of gibberish that I don't know yet. I have no idea what the name of this account's going to be. So if I had a sea of stuff in there, it would be nice to know what I just built in order to go reference that later on. And so this is a way for me to do that. And so let's go through, and once again, we're going to build the bicep file. So we're in O2 right now, and we're going to build the example 2. So we're going to do bicep build example 2, run through. Something I didn't mention earlier that is nice is if you have a failure in your bicep build or in your bicep file, when you go to build it, it does return back where those errors would be. So kind of like a compiler in that sense. So as I turn it from a bicep to a JSON file, if this finds issues with the syntax of my bicep file, then it will issue an error to me when I try to build the ARM template and allow me to go fix that. So we know we're making good JSON if this builds completely. And here we can see that that JSON exists now. So let's go take this file or this command, and we're going to copy that. You just do not. There we go. Oops, and now it did it too many times. All right, and then we're going to deploy it. So this is a new command, right? So in PowerShell, we use the new AZ resource group deployment command to deploy our ARM templates. When you use this command, it requires a name. This is what you'll see in the deployment section on the resource group for your deployment. If you use the same name, you will overwrite the other deployment. And I'll show you what we're talking about there once we deploy the storage account. But if you're redeploying the same thing over and over and over again, using the same name makes sense. But if I'm deploying, 2 different storage accounts for 2 different things, then I wouldn't want to reuse the same name because I would lose that I made one of those storage accounts, and I would want to keep that in my history inside Azure. So your name is kind of an important thing during your deployment. The resource group name is where you're deploying to. And so remember earlier when we look up here, come on. And when we look up here, this location where I said the resource group, if I'm not passing anything into it, it's using the location of whatever you deployed into. So because I chose to deploy into the RTP-SUG demos resource group, this resource group is going to use this, or this resource group function is going to use this resource group resource in Azure to find the location to deploy everything else into. And then I'm just defining the template file we just built so it knows what work to go do. So let's just go ahead and hit enter on that. And we'll wait a second, and this will build our first storage account inside our resource group.
Jeremy, this is Ed.
Yes, sir.
I missed it. When you did the first deployment where you were creating a resource group, what command did you use to do that deployment? Because you obviously didn't have the resource group at the time.
Yeah, so that one is something we'll talk about later. I honestly was hoping anybody would just, gloss right over that one. So if we go take a look, though, we can kind of talk about it, right? So where am I at? Oh, one.
I don't mean to sidetrack you. Sorry about that.
So the command that I use to answer your question is new AZ deployment, not new AZ resource group deployment. And that's because I don't have a resource group to deploy into, so I have to do a different kind of deployment. But a new AZ deployment doesn't support, like, in order to go further, we have to start talking about scopes, and that's something outside of the scope of this talk here, and I don't want to really get into that yet. But to answer your question, to make a resource group, it requires this target subscription because I have to change the scope at which I'm deploying. And then I run this new AZ deployment instead of a new AZ resource group deployment in order to create the resource group.
Thank you.
And then after that, everything else that we do, we're going to do using the new AZ resource group deployment, because most anything you want to make is a resource you're trying to put in a resource group. Yeah, that's when we go in part 2, we'll talk more about the different scopes and why we would deploy to different things. So, but in this one, I don't want to go that far out. All right, so let's take a look back here then. So again, remember we did an output for storage name and storage input, and here we can see the storage name, and here's my RTP sug prefix, and then some random that unique string generated on top of that, so that we know we don't get any sort of duplicate names. And then we also outputted our primary endpoints, and we can see all of those endpoints listed right here. If we wanted to be able to capture one of those and use it somewhere else, we could. So we're getting better, right? Like we went from making this very simple, not extensible thing to being able to extend it a little bit better, because now we've protected ourselves. We're not making things that are too expensive. We're not making names that are too long. We've started creating locations dynamically. So if I have resources deployed in different places, when I deploy into that resource group, I know my resources are getting made in the same place all the time. So I'm keeping resources geographically centered, right? So we're getting better, but we can still do this with a little more. And let's talk about what that looks like. So up here, I'm still defining my parameter inside the bicep file. So that means that every time I deploy this, somebody has to open the bicep file, has to change this value, has to recompile the bicep file so that they can make a new JSON with this value in the parameter in order to be able to deploy it. And that's not a very feasible workflow at scale, right? And so what we instead want to deal with is something that looks more like this one. Oops, this one here. So notice in this one, all of my parameters, with the exception of this one, don't have any values attached to them, which means that I'm going to pass these in a different way. So this time we're going to pass these in using parameter files instead of on the bicep file itself. If I want to, I can set a default value for a parameter by still continuing to use the equal sign. So in this instance, my parameter, my location, is set to whatever the resource group location is. But if there were, for some reason, a need to deploy this in a different location, inside my parameter file, I could specify a different location and it would overwrite this. And if I don't specify it in my parameter file, then it'll take whatever comes from this value. So what does a parameter file look like? Well, it looks like raw JSON. There's no way in the Bicep to create the parameter file, probably because this is a deployment thing and we're still deploying an ARM template, which is raw JSON. So I can turn this into my raw JSON, and then I will use this along with that in order to be able to deploy the resource. And so we can take a look at how that works, again, by doing the same thing we've done each time up till now. So we're going to first build the file. Well, we're first going to move into this folder, and then we're going to build the file. That's going to build my JSON file. And if we take a look again, we can look this way too. Notice here on my storage prefix, you can see the default value is set to RTP sug. And then here, if we look on my storage prefix, there just isn't a default value, because the expectation is that I'm going to pass the default value in a parameter file right here. And so a parameter file looks like this right here. So this is another one of those reasons why I say use the ARM template extension. So, oh yeah, Oh, maybe that I should also change that, shouldn't I? Now that the ARM thing's done loading, as I was talking about earlier, we can come up and look. So if I just type in the word ARM, you can see that it automatically gives me an opportunity here to do one. And if I select it, it builds an empty ARM template for me, right? So the same thing exists in, don't say that, inside my parameters. So if I have that extension, there's one in here that's called ARM-P. The P is for parameter, and this will build your um, skeleton for a parameter file inside here. And so I've already built one for this, and you can see here if we take a look. Nope, wrong one. Let me just close all of this. So if we take a look, I've got storage prefix and storage SKU that are required parameters. And then if I want to, I can overwrite the location of the resource group by passing in a location parameter. So if we look at my parameter file, I've defined in parameters the names of each of my parameters. So storage prefix, storage SKU, and location. And then inside each of those, you have to pass the value that you want to be set. So this time I'm going to use stage RTP-SUG. We're going to deploy it as a locally redundant SKU, and we're going to put this one in West US instead of East US too. So that's all it's going to take. And what we're going to do different is when we go to deploy this one, when we go to deploy this one, we want to use an extra switch. So let's have a look at what we just wrote in here. So can everybody see that? It's not getting cut off, is it?
Looks
Y'all
good here.
Okay. All right, so we're going to use the same new AZ resource group deployment. We're going to come in and we're going to change. Oh wait, what did I use on the last one? Is that different? It is not. Yeah, so we're going to come in here. Let's change that to -2. And then, so we're going to give it a name for the deployment. We're going to tell it to go into a resource group, the RTP-SUG demos resource group. We're going to tell it to go into or that we want to deploy the example1 file, and then we're going to add in the template parameter file, and then pass in the name of that file as well. The normal nomenclature to build a parameter file is whatever the name of your ARM template is. So example1.json, you'll do the same thing, but you'll either put param or spell out parameter in between them. So I'm lazy. I don't want to spell out the extra ETR every time I do this. So I run example1.param.json. And now that's going to glue this data into this file here, making sure that wrong one. Into this file here, making sure that this storage prefix, this storage SKU have values, and then we're going to overwrite the location of the resource group and build a storage account in a completely different location. And then we'll just hit enter and go take a look at that. And in this one, again, we've updated our outputs. So we'll see the name, the primary endpoints, but I've also thrown in the location. So as soon as this is done, right away, we'll get to see that this was built in West US. And then here we take a look. Storage name is this, built in West US. Here's my endpoint. And if we come over here and take a look, whoops, stop. Do a refresh. We'll see both of our storage accounts in here. Wait, where's the other storage account? There it is. And you can see here as well, our locations are different. Now that we have two of them, let's take a look at deployments. So on the resource group, whenever you deploy something, and this isn't with ARM, even if you deploy something using the portal, if I came up to, my resources, clicked over here and said, I want to create a resource. So when you're done with this and you come back over here and you look under deployments, you're going to see that resource that you built down here. And this is why I said you want to make sure that you do change the name unless it's something you're continually overriding on your own. So because if I continue to keep RTP-SUG stage as the name of that deployment, we wouldn't see that I built a second storage account here. I would have overwritten the first storage account I created with all the data from the second storage account I created. And we want to keep the running log, one, because it's good for auditing, and two, if I ever need to replay something, it's nice to have it in here so that we can go back and replay that. So, and in this, we can actually see the information about my deployment over here. So that's why you don't really want to overwrite this data. We can also see, no, that one. We can also see the template that was built. And if you go and look inside the portal for something that you made, like inside the portal, if you just go take a look, you'll be able to see the JSON that they use to create that thing after you went through the wizard by coming in and looking at that most recent deployment and clicking on template. And so this is a way for you to kind of understand what choices you're making and the wizard does in the ARM fabric as well. All right. So that's how we build a parameter file. The last thing that I want to show you is that, remember in the beginning, I said that a bicep file is a declarative thing. So all we're doing is specifying that we want this thing to always look a certain way. So what we can do is we can take a look at this real quick. So I'm here, I'm just going to make another storage account. So we're creating a prefix, a SKU, a resource group location, going to generate a unique string, build the resource, and then we're going to output the name, the location. We're going to take a look at the SKU that we created, and then we're going to have a look at its primary endpoint. And just like before, I have a parameter file here. We're going to get rid of location. We don't need location. So I have a parameter file here that is going to create a prefix. So we're going to call this one dec_rtp_sug, and we're going to create it as locally redundant storage. And so all I have to do is come back over here, and as we've said every time before, I'll say it with me this time, bicep build, and then you go, whoops, first we have to change directories. I'll get that with me. Now bicep build. And then build our JSON file. And then we will deploy that. This time we're going to say we want to do a new AZ resource group deployment. We'll call this name, and then we'll say RTP sug dash deck1. And then we want to deploy this into the RTP sug demos group. And we want to use a template file that is example1 and a template parameter file that is example1 param.json. So here we go. So now we're going to build this file, or we're going to build this storage account, dec_rtp_sug, as a locally redundant storage.
While you're waiting for this, Clem had asked couple of minutes ago, the template files and the template param files accept YAML or only JSON?
That's a great question. I think only JSON, but I'm not sure enough to bet on it. I'm going to guess only JSON. I know that the ARM template can only be JSON, so I wouldn't expect that the parameter file would be anything other than JSON, but I've never looked to see. Okay, so here we can look, so we can see that we've built our unique storage account. It's in East US2 and it's locally redundant storage. And now what I'm going to do is change my L to a G, save my parameter file. Because this parameter file is using the prefix and then the ID of the resource group as its seed, then I know that I will always compute the same name for this value, right? So if I go and redeploy this, I know that I'm going to end up with this same storage account name again, which means that I'm going to be redeploying this storage to as the same thing all the way around, which means that the only thing that I'm doing is I'm telling the storage account to not be locally redundant and instead be globally redundant. And so if we come back through and we do this again, and all I'm going to do is change this to a 2, because I haven't changed my bicep file, right? And this is why parameter files are important. My expectation for my output hasn't changed for the way that it's built. Only the property value for the SKU has changed. So I'm going to build the exact same file. I'm just changing that from locally redundant to globally redundant. We're going to run that, and we're going to wait again. And where the first time you can see that it was actually built locally redundant, and then what I should have done is come over here and look. We might still be able to see that time. Go back to overview. No, it's definitely going to be too long now. Probably already done building. Yeah, so it's globally redundant here already. And you can see that here. So that means that this is already outputted that I have a globally redundant instead of locally. And then I can flip it back again if I want. So why don't we do that? So we'll just save that. Down, redeploy this one more time. Call this 3. And I'm purposefully making sure I don't step on my deployment files for tonight, just so that we can see all of these things line up. And now we can see that it went from globally redundant back to locally redundant. And if we look inside our portal, you can see here as well that we've gone from globally redundant back to locally redundant. And so that's where I wanted to point out that whole, it's declarative, right? I'm just telling the ARM fabric what I want my end result to be. It goes forth and makes sure that that happens. And then if we go take a look again at deployments, you can see all of my different deployments. Now, in this instance where I was flipping back and forth, I may have wanted to overwrite the original deployment for that. If I made a typo and I was like, oop, that wasn't supposed to be globally redundant, that was supposed to be locally redundant, then I could have left this, originally right here with my deck 1 and redeployed. And when I redeployed, I would have overwrote the first deployment with the second deployment. And so you would have just never seen that I misdeployed the setting and then corrected it, at least in my deployments. The audit log, you still would have seen that, but not here. And so that's where you can make decisions one way or the other. And then, like I was showing you, or like I mentioned in the very beginning, if we go all the way back up to 01, take a look. Remember, I had an empty ARM template here with nothing in it. This alone, if you take nothing else away from this, when you're playing in Azure and you have all the stuff to delete, this is the best way to do it. So there's 2 modes when you go to do a deployment. So if we do back over here, and we do a new AZ resource group deployment. We call it name, and I'm going to call it erase all. And then the resource group that I want to deploy this into is RTP sug demos. And my template file is going to be example1. I don't need a parameter file, I'm just deploying an empty template, but this time we're going to add one new switch called mode. And mode has two different values, complete and incremental. The default value is always going to be incremental, which means that anytime I deploy an ARM template into a resource group, I'm stacking on top of what I've previously deployed. So if the resource exists, then I'll be updating that resource with new properties. And if that resource doesn't exist, then I'm going to create that resource. But I can come in and choose to say I want to do a complete deployment instead of the default incremental deployment. And what I'm telling the ARM fabric to do is to deploy exactly what I have in this single definition. So whatever I've declared here is the only thing that will exist once I'm done with this deployment. And this is why that's nice, right? Because if I have a lot of things and there's parent-child relationships and I have to get rid of certain things before I get rid of others, and I'm sure anybody that's been playing in Azure has experienced that, where when you go to get your resources and delete them, you'll get errors about how you can't delete certain things. And you have to run that get everything and delete everything PowerShell line 2, 3, 4 times before all of it's emptied. I don't have to do that this way. I can kick this off. It's going to say, are you sure? You're going to say, trust me, I'm a professional, and then hit the enter key. And this is going to go through and do a complete deployment of making sure that the resource groups, RTP sug demos, has exactly nothing in it. And I don't have to worry now about whether or not there's certain things that have to get deleted before other things. The ARM fabric takes care of that for me. I'm left with an empty resource group.
That's a pretty cool tip.
Yeah, this is super easy, right? I deploy empty ones all the time for that reason, because it's just so much nicer than being like, go do this. Okay, now I got to do it again. Okay, now I got to do it one more time. Finally, we're empty. All right, and while that runs, the last thing I wanted to show you was here I have an example of a basic VM deployment. So it's everything that you've already seen today, just a little bigger, right? So we've got a few more parameters because we're building a few more resources. And if you scroll down, you can see here, we've got to deploy the storage account. They're deploying a public IP, the network security group, the virtual network, the NIC, the VM. And they're all going to stack on each other, right? Because like I'm going to put this NIC, scroll down here. I'm going to put this NIC on this VM, and I want this NIC to exist on a specific virtual network. And I need a subnet on my virtual network, right? See how it's all being nested in together and works. Now I stole this one just so y'all can see it, so we can talk about how you can start to play around with some of these bicep files on your own. If we go back over and take a look in here, there is, all you just type in is GitHub, Azure. Yeah, you could do ARM or Bicep. Either one will take you to the same place, right? So what we're looking for is this quick start templates. Inside this GitHub repo, there's something called quick starts. And here is a list of all of the different types of things that you might want to make. So if you want to start with making a VM, we can go to the computes. And then here's all the different styles of VMs that you can build. And so they show things like if you want to look at what a template file looks like to build something that's got 2 VMs on a load balancer, then we can go in here and look at that. you want to see how to build a Linux VM that's got an encrypted file system, then here's a template that you can use to start with. And the one that I just stole should be a VM Windows or simple Windows. And then inside here, they'll have the main.bicep file. And when you take a look at that, this is what I have copied over on my side. And so there's a bunch of quick starts that exist inside GitHub. So if you're somebody who likes to see what exists and then use that to build on your own, then go grab these quick starts out of here and work off of those. If you're somebody like me, I would prefer to just start on a blank slate and build the simplest thing possible and then work my way up. Then by all means, go forth and do that. So storage accounts are a really good thing to start with when you're building at the beginning, because there's very little requirements around a storage account. I can go through and set the properties that I want across that storage account. I'm not tied to being region centric with them. There's, I don't have to worry about a bunch of other things that need to be created before I can build the storage account. So I would suggest when learning this, start with a storage account as we've done today. And you can go in and build those properties larger on that storage account to make that storage account a little more robust. And once you feel comfy with that, then move over to something a little more complex, like a virtual network or a virtual machine, where we have to have multiple resource objects being created at the same time in order for my deployment to succeed. So that was the last thing that I wanted y'all to see. Anybody got any other questions?
So we got one question here from David Stein that I'm a little bit confused on, but when he builds an automation account, an Azure automation account with Terraform, he can upload runbooks from local files. He wants to know if Bicep supports that scenario also.
I don't know. I don't do a lot of Azure automation in my Bicep files. So I'm not sure what is available and what's not. We can probably go take a look though. Let's go take a look.
I was looking at Clem's post. I didn't know, Clem, were you responding to that question?
No, I was just dropping in the GitHub link for those so that
Okay.
if people didn't have it in the chat history, they didn't see what he did in the web browser to get the repo that he was using for his samples.
Gotcha.
Preach.
Yes. So the question, maybe I was being too specific, isn't really so much about just Azure automation, but the idea of if there's anything in Azure where you would normally create an artifact in Azure, like a file, or let me get a better example. Okay, storage account. Let's say you have a storage account and you want to put files in that storage account in a container, like a sample file. I wonder if it supports that, or do you have to like literally spell out the contents of the file and say write this to that, something like that?
Yeah. So a lot of those, it's going to fall on like it depends, right? There's a concept of extensions that run. So like in the for the storage account one, I know that there is an extension where I can actually execute a PowerShell script that will go forth and do what I want it to. So once I know what that primary endpoint is, I can feed that into my PowerShell script and then connect to the primary endpoint and copy files into the blob storage or whatever I need to do with that PowerShell script, right? So taking data from one place, putting it in another. But that's a unique extension that exists for the storage accounts. I have one. If we take a look, like we'll just go over to my GitHub real quick. That's probably the easiest way to is it in this one? Let's go look and see. Network interface, virtual machine. No, it is not. Okay, so I don't have one. not here anyway.
Okay.
Because this is all the stuff that I'm working on for the other talk. And I thought I had already built something that had, but we could just do this. Let's try then. Azure Bicep VM domain.
Oh, okay. So it looks like it does. I'm looking in the API docs under automation accounts, and then under there's runbooks. And runbooks has a content link,
Okay.
with me, link, and that supports a URI that gets or sets the URI of the runbook content.
There you go. Sweet.
Okay. So,
So if your content's already available, then like in a storage account, then you'd be able to pass it in.
okay, cool.
Yeah, and those are the questions like I don't know everything there is to know about every possible resource that could be made in Azure. So that's why I was like, yeah, you kind of got to find your way for the things that you're deploying. In my job, I'm a plumber, so I deal a lot with virtual networks and backups and virtual machines, app service plans, that kind of stuff.
Yeah, this is very
I don't
helpful.
deal much. But yeah, so cool. And then just so you can see, like here's an extension for joining a virtual machine to a domain. And so this is added on to making the virtual machine, right? So once you have the virtual machine made, then I also attach this extension and join it to a domain. And then for my organization, we have multiple domains. And so depending on who's creating it or which domain they specify in a different parameter, I'll default to a specific domain to join and then join into the appropriate domain. Things like that. Other questions?
Jeremy, this is Ed. I do have one question for you. Early on in your demo, up in that first example, or actually throughout the whole thing, where you were building your name of your storage account and pulling in a parameter and adding the resource ID of the resource group. Can you just walk through the syntax of that string there for a second? Like, what are the two $signs doing versus
sure
it's just parsing out that. It's just enough different that I need a little help.
For sure. So let's do var foo equals some value, right?
Mm-hmm.
All right. So I've identified this thing, which honestly, realistically here, I would probably have this as a param. So we can do param foo equals some value.
Okay.
I need to say that that's a string. All right. So I've got this parameter now that somebody's passing some data into, and I'm setting the default data as some value. And then I want to add that to a different string that I'm about to build. So if I just do foo, then now bar equals foo. But if I do foo, now bar equals the string foo, not the parameter foo.
Mm-hmm.
So I've lost some value and I've become foo. And if I put, where's it at on my keyboard, $, and then throw it into brackets, feels JavaScripty, right? So now I've told Bicep to expand this variable. So I've picked some value back up into bar.
Okay, so the $ curly braces are basically doing the same thing that $paren does when you're building strings in PowerShell.
Correct. Yep.
Okay.
And
So
all right. In this instance,
token replacements.
Yep. So in this instance, you can see I've got two single quotes because I'm creating a string. But my string is computed by the parameter value. So I need to expand this storage prefix as the first part of the string. So that's what this part is doing. And then I want to create a unique string requiring a seed value. So that function exists to build something else. And then all of that exists, here, right next to RTB_SUG to compute just the long single string inside the quote.
Mm-hmm. This is a sign that I'm just getting old, because every time I looked at it, I saw dollar open curly variable, close curly, close dollar, and never caught the closed curlies or the open and closed curlies around the second variable. So I was just splitting my tokens in the wrong place.
Well, they are really tiny, and I was moving a lot, so I'm sure it's not the easiest to follow. Any other questions?
I think we're good.
Sweet. Well, this has been great. I hope it was helpful for everybody else. I really enjoyed it. So if y'all have questions, hit me up on Twitter. So head to the RTPSUG GitHub tomorrow, and all this stuff that we created tonight will be, well, I'll be deleting all the JSONs again. But the bicep files and the parameter files will all exist over in RTPSUG, or if you want to take a look at my GitHub, they're already up there on my GitHub.
Jeremy,
So,
thank you so much for presenting tonight.
hey, thank you. I had a great time.
Yeah, man, I think you did a fantastic job. And for the people watching at home, remember, this is part 1 of 2. We're going to have the second part coming up in the near future. We haven't scheduled the date yet, but this was recorded in August. And so the video will be available probably even before we schedule the second talk. If you'd like to come and join us in person, visit rtpsug.com or find us on Meetup, and you can join us for the next presentation live, and you can ask your questions of our presenters. If you've made it this far, please check out some of the other videos we have on our video channel. We have over 120 presentations related to PowerShell. There's sure to be something there to pique your interest. So if you could, like and subscribe to our channel and keep up to date on what we're doing. We're going to say once again, thank you to Jeremy, and hopefully we'll see you all again soon. Have a great night, everyone.